right, page 235. You had numbers 2, 4, 5, and 7. Have that homework out if you would, please, so I can come by and check. Page 235, numbers 2, 4, 5. And you're doing it now. See there? I told you it was contagious. 2, 4, 5, and 7. We were actually not doing the review. We were doing the practice like we done in class, but I guess I didn't make that clear. At least not for one person. 2, 4, 5, and 7 was the homework. So if you did the review and you're watching on YouTube, you have a chance to very quickly do the practice 2, 4, 5, and 7. And if you're in the classroom, well, you just have to do it. Now, before we get into that, let's go ahead and review over some things we talked about. We talked about this set of two equations, often linear equations, at least that's what we've done so far, a set of a couple linear equations that we would solve together to get x and y. And what do we call this set of two equations, Maddie? Well, each one is a linear equation or an equation, right? But if you put them together in a set, we don't call it a set, we call it a system of equations, a system of equations. And why did we need a system of equations to solve for x and y, Brandon? And we got by them until just a couple lessons ago. We didn't do any systems of equations. What do we need systems of equations? Oh no, you're thinking parabolas here.
To find the intersection.
To find an intersection of x and y, because we said by itself a single linear equation has an infinite number of coordinates within it, right? A straight line, or any graph, in fact, has an infinite number of points that make up the line, or even if it were a quadratic, an infinite number of points in that parabola. So if you wanted to find x and y, you'd have an infinite number of answers. We would describe that single equation in class as being indeterminate. Class, what is it? Indeterminate. Why is it called indeterminate, Audrey? Infinite number of points, infinite number of answers, right? We need that second equation, Brandon, to find where the graphs intersect each other. And where they intersect at a particular point, or if it's like a quadratic and a linear, at a couple of points, those coordinates are the x and the y values. So we can solve for two unknowns using a system of equations. Two unknowns, two equations. By the way, later on, just I guess a week and a half or so, we're going to get to three unknowns. Well, we're going to need three equations. If we had four unknowns, we would need, class, four equations. Heaven help us. If we had 10 unknowns we were solving for, we would need 10 equations. Okay, so as many unknowns as you have, you need that many equations. And since we're dealing with x's and y's, two equations will help us to solve. What we're shooting for is what Abby mentioned, and that is that the graphs would intersect each other. Well, how do we get, what kind of system has graphs that intersect, Genesis? A type of system has graphs which would intersect at specific points, or a specific point if they're linear. Michael?
Can I buy a vowel?
You buy a vowel, there's an O in it.
Constant.
Close. Consistent. A consistent system of equations. The graphs will intersect. And if the graphs don't intersect, Genesis, then we have opposite of consistent. Try again. Make it all one word. Deconsistent. Not deconsistent or disconsistent or unconsistent, but no, not non-consistent either. That was a good guess too. Help me. No, not non-consistent, class. Inconsistent. Okay, inconsistent. Anyway, poor Matt. All right, the inconsistent system. Okay, so class, there's not that many terms to know, but you have to know them. They intersect, class, we have consistent. If they're linear, why would they not intersect? If they were parallel, right? Parallel lines would intersect. Okay, so if they're parallel lines, they don't intersect, they have the same slopes, then we would have an inconsistent system. Now, by intersect, again, let's just take, for instance, two linear equations. They intersect, we get 1 point, an x and a y, right? That's two values, hence two equations in the system. When you get an x and a y, you get a set of coordinates. It's also possible the two lines can intersect by actually coinciding with each other. If the graphs coincide, if the lines coincide, we would describe the equations from whence we got the lines. we would describe the equations as being anyone? Dependent. The equations would be considered dependent because the graph would be coincident. All right, in that case, how many times do they intersect if they literally coincide? Infinite number of times, so the solution is still indeterminate. We're going to look at that a little bit more today. So, they never intersect, class. Inconsistent system. What's the answer? No solution. They never intersect. If the graphs do intersect, we get consistent system. We get our answer, and that's happy. Unless it's consistent to the point of literally coinciding, then we would describe the equations within the consistent system as being dependent. If they're two separate lines, then the equations are the opposite of dependent. Independent. Yeah, independent. Okay? Different from each other. Everyone laughs, but Maddie, she just glares at her book. All right. Safer than glaring at the teacher. All right. However, all that graphing stuff, right? We said we don't really want to graph, right? Especially if the answer doesn't come out to a nice, clear point, you know, integer values for x and y, it's really hard to read that graph. We saw one the other day where it was, I think, 1 1/3 and 1. It's like, how do you know if it's 1 1/3 versus 1 1/4, 1 1/2? It's kind of hard to tell. And then even then, if they might be supposed to be intersecting, right, on a point, a specific integer value x and y, but maybe my graph is just the tiniest bit off because I'm not perfect. Let's just pretend I'm not perfect, and so my graph is a little off, and I can't really tell if they intersect perfectly right at, you know, where to get integers for x and y. So graphing is just a pain. So we came up with another way of solving our systems of equations. It's so much faster, so much easier, and so much more accurate. Perfectly accurate. What was that method we began working on in our last lesson? It seems like ages ago. We just did a 3-day weekend in their defense, so if they feel kind of, how do they not remember this? They just came off a 3-day weekend. Genesis, how was the way we just talked about solving our systems? Good, the addition method or the elimination method, either way to describe it will work. And that's what we were supposed to use on numbers 2, 4, 5, and 7. Now on number 2, they gave us the equation 6x minus y equals 18. And they gave us another equation, 2x plus y is equal to 30. We said when using the elimination method or the addition method, it's important to make sure that our terms are lined up with other like terms. Oftentimes you'll see that be the case because these are both in the standard form where we have our x's, our y's, our equal signs, and our numbers. If they weren't lined up, we'd have to get them that way. Once we've lined up our values, we want to pick a variable class to eliminate, to get rid of. Do we want to get rid of the x or do we want to get rid of the y? Michael?
The y.
I'm lazy and the y is perfect. All I have to do to get the y's to cancel is simply
add them together.
Add together. And they're going to cancel. Now, what if, you just were, you like to make life hard and you want to get rid of the x's? Well, what would I have to do to make the x's match? First of all, class. If I multiply the bottom by a 3, do we see right here, Genesis, I get a 6? Well, that matches this 6. But does a 6 cancel with another 6, class?
-3.
No, but if I multiplied a -3, or multiplied a 3 through here, and then changed all the signs on the other one. Here's the reason why, by the way, I do that. This would give me a 6, this would give me a 3, and this would give me a 90. Those are all bigger than the numbers up here, correct? I'd rather make the little numbers negative so that my answers here are positive, because I hate negatives. So generally, if you want to jot that in your notes, when you change all the signs in an equation, do it where the little numbers are. But here, it's easier just to add, make the y's drop out. We end up class with 8x is equal to 48. Very quickly, we've already got our abscissa, class, 6. But we're not done. Remember, we need to solve for both x and y. We need the coordinates of where these would intersect if I had taken time to graph them, and I was just too lazy. So let's take the 6 and plug it into one of these two equations. And Abby?
Into the 2x.
All right, so we plug it in here. Of course, 2 times 6.
12.
And since it's a positive 12, we'll move it over as a negative 12 to get y is equal to?
18.
Aren't you glad you didn't have to graph this? Because where would these two lines intersect, class? 6, 18. That's the point of intersection. But I did it all without graphing. Did a lot faster and didn't have to have a massive, large graph grid in order to get all the way out to 6, 18. How many had 6, 18 as your answer for number 2? Did anyone happen to get rid of the x first? I assume most of you got rid of the y. Always do it the easy way. The next one you had was number 4, where we had a negative 3x, negative y is equal to 24. We also had a 4x, negative y is equal to 10. And Here, nothing cancels right away, but I can get things to cancel very easily, Kendall.
You can change all the signs at the bottom.
Okay, to make this a negative, this a positive, this a negative. Now what cancels?
The y's.
The y's, leaving me with class is correct, Audrey. And then here the 24, negative 10, class 14. So we end up getting, Abby, x is equal to?
-2.
-2. Once I've got the x, again, you don't always get rid of the y, so we don't always solve for x first, but once you got one of them, either x or y, you go ahead and get the other one. How do I go about getting the other one, Abby?
You plug it in for the one of them.
Good, which one? Your choice.
The -3.
All right, so we're going to plug the -2 in here, so that -3 times -2 gives?
6.
Positive 6 minus the y equals 24. We could either do a double switch now, or we could just send the 6 over and remember about the negative in front of the y. What do we end up with for the y here, Abby?
-18.
-18. So if we had taken time to graph class, where would these two graphs have intersected? -2, -18. Again, glad we didn't have to actually graph them. How many had this answer for number 4? All right, let's go to number 5, where we had an x positive y is equal to 4, and a 3x positive 2y is equal to 4 as well. And Genesis, we've already got them lined up, which is nice. I need to pick a variable to get rid of. Which letter do you want to eliminate? Okay, so to get rid of the x, Genesis, I need to make these match but have opposite signs. So that means that I'm going to have to multiply. Okay, the top by -3. So what does my top equation become if I multiply it by a -3 all the way through?
-3x plus -3y equals -12.
There we go. Now here's an example of where I would have multiplied the 3, and then see how these numbers are smaller. 3, 2, and 4 is smaller than 3, 3, and 12. I would have actually put the negative through here, just so I don't have negatives. But it's not a problem. Okay, it's not wrong. When I add then these equations together, my 3x and -3x will cancel. The 2y -3y, and the 4 -12.
8.
So what is y if negative y equals -8? No, negative y is -8. What is y?
8.
Just 8. And then we're going to take the 8, go back to one of my two originals. Easiest choice would be the top. Plug the 8 in here, and if I move it over as a -8, I'll get that x is equal to -4. So if I had graphed these equations, class, where would they have intersected? -4, 8. So what kind of system would this be if they would have intersected at a point? Consistent with independent equations. How many have -4, 8 for number 5? Okay, questions number 5. Questions number 5. All right, and then number 7 was the last one you had to do. We've got a 4x positive y is equal to 10, and we have a 2x positive 5y equal to 20. And Michael, again, they've already lined up the x's and y's for us, which is awfully nice of them. I need to pick a letter to get rid of.
The x.
All right, so to get rid of the x, I need to multiply
The bottom by -2.
Okay, and again, I would argue multiply by a 2 and then figure out which one's better to change the signs in, but you could multiply a -2. What does my lower equation become if multiplied by a -2?
-4x and -10y -40.
Equals -40. Again, I'm looking at this top equation and this revised bottom equation. To get the x's to cancel, all I have to do, class, is add them. And when I add them, here, these cancel. Y and -10y, Michael.
-9y.
And 10 and -40.
-30.
And of course, again, if you wanted to, it's as easy as just canceling the negatives there, which is why it's definitely not a problem to multiply the -2. Again, my only caution would be when you try to multiply the negative, if there had been a negative in here somewhere, it'd be easy to miss the double negative and the positive. So again, maybe the negative in a separate step, but I digress. It doesn't divide evenly by 9, but if I take 30 over 9, I can at least reduce that down to, because I don't want to leave 39ths.
10/3.
10/3. And I will leave 10/3. Now there's my ordinate. Now we've got a choice to make. It's not particularly pretty, but we do have a calculator, right? So I could plug this back into one of my two equations, and I could just let my calculator help me to solve it. Or, since I canceled the x to solve for y, to solve for x class, I could cancel the y. So that's another option. Going back to the original system here, if I wanted to cancel the y's class, I would need to multiply the top by 5. So that my top equation, I'm going to come over here now, top equation would become what, Brandon?
20x plus 5y equals 50.
And my lower equation for now is a 2x positive 5y equals 20. Where are the smaller numbers, class? In the bottom equation. That's where I'm going to change the sign so I don't have to worry about negatives. Obviously, we see the 5y, negative 5y cancel. 20x, negative 2x, class. 18x, 50, negative 20. 30, divide both sides by 18. Well, let's go ahead and reduce 30/18 by 6 to get 5/3. And there's 5/3. I believe that's what you should have gotten even if you put the 10/3 in, subtracted it, and divided by 4. I think you still would have gotten 5/3. How many had 5/3, 10/3 as your answer? How many did like I did and you just solved it a second time? How many plugged the 10/3 in and used the calculator to get it? Both ways are fine, you just got to be careful with the calculator. Any questions at all on 2, 4, 5, and 7 from the homework? Any questions? Let me give you a couple problems to work at your seats. Seems like we did a good job on the homework, but let's go to work a few more. Just get our brains fully in gear here on this. Feels like Monday, really Tuesday. Happy Tuesday. All right, got a 3x, negative 2y equals negative 1/2, and 2x plus 5y equals 6. Thoughts even as you're writing it? How many thought, ugh, as you were writing it? Yeah, me too. What can we do to take care of the ugh?
Multiply the top by 2.
Multiply everything by the LCD, right? Which in this case is 2. So if we just multiply the top by 2 everywhere, what does that top equation become? Michael?
6x negative 4y minus 1.
Equals negative 1. And now, if I go ahead and bring the bottom equation over as a 2x positive 5y equals 6, which if you're lazy you might not, now I don't have fractions, right? So if you see fractions, just get rid of them and move on with life. At your seats, finish it out now. It's the old saying, don't be mad, get rid of the guy who bugs you.
Wait, what?
No, I mean, don't be mad, get glad. That's what I was afraid I get my old sayings mixed up sometimes. Got it. Brandon's got it. Okay, I wasn't sure if you were playing on the calculator or if you were still calculating. Kendall's got it. Audrey's got it.
Do you guys actually push up your glasses like
Who? Yes.
people with glasses? Do you actually go like that?
I don't know.
Do you have glasses?
I don't know. Where did that even come from?
I don't know. I just started thinking about glasses.
All right. So on that note, let's go ahead and take a look at this. Now, I said if you're not lazy, maybe you go ahead and rewrite this bottom equation. As I'm copying this, I've got one I over here. I'm like, I've got a 2x and a 6x. I've got a 5y and a negative 4y. And my lazy self, who doesn't want to recopy this, is already kind of thinking ahead, which letter am I going to shoot for, the x or the y, class? Almost definitely the x. So instead of bringing this over, let's also multiply the bottom equation by a a 3 initially at least to get.
6. Negative 2 minus 18.
And hopefully you did this anyway, right? Even if it took a separate step for you, hopefully you did that. Now, where are the little numbers, class? In the top or bottom? Top. So I'm going to put the negative through the top, which involves changing these signs to positives. I love being able to do that. So the only negative is right here where the 6 and x and negative 6x. I'm dealing with all positive numbers. I like that. Here that gives me 19y equals 19. I'm not as likely to screw up positives as I am negatives. Y equals 1. How many got the y equals 1? And then to finish solving, I go back to one of my originals. Well, not that one. So let's come to this one here. And 5 times 1, class? 5. Subtract that 5 over to get. And if 2x equals 1, then x, class, equals 1/2. So how should I write my answer? Kendall?
1/2.
1/2, 1. And there we go. How many had this answer here? All right, questions on that? All right, let's do another one. Now, x and y are the most commonly used letters, but you realize you could use other letters as well. For instance, writing this down, 2b plus 5a equals 16, and 3a positive 9 equals 5b. The key here is you would want to use alphabetical order. So instead of x, y, think a, b. We're going to solve it much the same way. Though this time, what are you going to have to do to start out, class? Line them up. Line up those like terms. All right, so how did you rearrange things to get like terms lined up here? Audrey?
I moved the 5b over as negative.
All right, and you put it up here at the beginning?
Mm-hmm.
All right, and then
Then moved the 9 over as negative.
all right, so that your, what was bottom equation, I'm going to go and write it up here, became what?
5b plus 3 equals -9.
There we go. Okay, how many did the same thing Audrey did? Anyone kind of flip-flop and put the a's first, then the b's? So you had the 3a minus the 5b equals -9, and 5a plus 2b. Doesn't really matter as long as they're lined up. That's the nice thing. Which letter did you want to get rid of here, Genesis, the a or the b? The a? Now, to get an a, you would need to turn both of these coefficients into what number? 15. So that means you need to multiply the top equation by a, and the bottom equation by a 3. Had you chosen to get rid of the b, what number would you have been shooting for? 10, which means the top equation would be multiplied by, and the bottom equation by. I'm lazy. I'd rather shoot for a 10 than a 15 because 10 is smaller, and I like little numbers because they're easier. Also, there's another thing that in my mind makes the b easier than the a. Anyone? These signs are already different, right? So I don't have to worry about then picking where to put a negative. So I would have picked the b given the choice, but let's roll with the a anyway. And but I do want to kind of show strategy, right, on how to make life as easy as possible to allow you to be as lazy as possible. You said multiply the top by 5, bottom by 3. What does my top equation become when I multiply the 5? Genesis?
For 25 plus 15a equals -45.
All right, and then the bottom equation you said by a 3.
6b plus 15a.
3 times 16, 48. Now, Genesis, right now, will the 15a's cancel? No, because the signs aren't different. Where should I put the negative, top or bottom? Do you see I've already got negatives in the top? If I put a negative through the top, Genesis, what's it going to do to those negatives?
It's going to change the signs
into positives here, right? I like that. So let's change them in the top. I'm going to disagree with you enough here. So let's go through the top, change all the signs. So we get a... There we go. So now, yes, the 15a and negative 15a cancel. But right here, I just have positive. It's happy. It's easy. It's...
B equals...
Calculator helps on something like this. And so we end up getting b equals, and it works out evenly to a nice integer value. 3. Once I've got the b as 3, I can go back to any of my original equations, even this one that's solved kind of weird, right? I can even go here and plug in the 3. Class, if I do 5 times 3, 15, subtract away the 9 from the 15. And if 3a is equal to 6, then a is equal to 2. So how should I write my answer? Well, normally I put x, comma, y in parentheses. Where it's not x and y, I'm going to go alphabetical a, comma, b. So my answer, class, would be 2, 3. And how many had this answer, regardless of the way in which you approached it? All right, questions on this? Questions on this? Let me give you one more, and then we're going to move on to something, a little bit of an extra twist here. Let's go with 2s plus 8t is equal to 7, and 7s plus 12t is equal to 12 and a half. For sake of time, let's take a look together and see how we were doing. How many saw the half and immediately thought, I got to get rid of that. I can't be dealing with the half or the 0.5. In my case, I went ahead and showed the 25 halves, the improper. So when I multiplied the 2, it's an easy 14s, 24t, and cancel the 2 to get the 25. At that point, it's like, well, I can either go 2 and 14 to get 14, right, top by 7, or I can go 8 and 24 to get the 24, multiply top by 3. Well, I'd always rather multiply by 3 than by 7. So I multiplied the 3 all the way through to get a 6s, a positive 24t, equal to 21. But the 24t's wouldn't cancel unless I changed the sign. So I went through the top, because that's where the little numbers were, change the signs to get 8s, cancel, equals 4, s is a half. How many got the s is equal to 1/2? Now, oftentimes, if I get a fraction, I'm like, I ain't plugging that fraction back in. But let's face it, 1/2 isn't that bad of a fraction, right? Especially not if I plug it in right here for the s. Not this s. Half of 7's a pain. Half of 2 isn't. What's half of 2, class? 1. So this just becomes 1 plus 8t is equal to 7. Move the 1 over as a -1 to get 8t is equal to 6. And when I divide away the 8, I end up getting an equally annoying answer for t. Reduce it down to get 3/4. So how should I write the answer? Well, remember, alphabetical order. And here you're like Q, R, S, T, U, V, W, X, Y, Z. Which letter comes first alphabetically, class? The S. So we're going to put 1/2, 3/4. And that would be a real pain to see on the graph, right? But not a problem necessarily doing it with the addition or elimination method. How many have 1/2, 3/4 for the answer? Okay, only a few of you. Questions, comments? We figure out what we did wrong, or maybe some of us just didn't have time to finish. I suppose that's a possibility as well. Questions? Any questions on the elimination method or the addition method? All right, now one of the things we talked about with graphing was it's very easy to spot an inconsistent system, right? In an inconsistent system, you can see the parallel lines. You probably even see as you're plotting the slope, hey, this slope is the same as the last time. So inconsistent systems are easy to spot. You're on page 235. Copy down number 9 if you would, please. Go and copy down number 9, where we've got a 2x plus 6y equals 10, and we've got a -3x, -9y equals -8. Number 9 from page 235. How will you spot an inconsistent system if you're doing it algebraically? Well, you start the way you would any system, right? You don't know going in what you're going to get, but you want to make sure like terms are lined up. They are. You want to pick a variable to get rid of. Maddie? The x's. And you say, 2 and 3 can both become what number? If we multiply the top by? And the bottom by 2. Okay, so what does my top equation become now? Michael?
6x positive 18y equals 30.
And the lower equation is going to become what, Brandon?
-6x, -8,
-18y equals -16. And then when I add the equations together, notice what happens. My x's, class, my y's, literally what is left on the left-hand side? And what is left on the left-hand side? Nothing. How do we say nothing? 0. On the right-hand side, 30, -16. Is that true? That 0 equals 14? No, that's a lie. We'd call that a contradictory equation, wouldn't we? If you arrive at a contradiction, you know it's because you have an inconsistent system. So therefore, my answer, just as it would be for a contradiction, class, no solution. Does it make sense how to spot an inconsistent system? You'll arrive, Genesis, at an inconsistency, at a contradiction. 0 does not equal 14. It never has. Never will. Right? So, no solution. Questions on number 9? Let's take a look at number 11. Go and copy down number 11. And we've got a 3x, positive 6y equals 27, and a -2x, -4y equals -18. Again, we approach every problem the same. Make sure the x's and y's are lined up. We pick a variable to get rid of. Abby, head offhand. Which letter?
Get rid of x.
X. All right. So we need to multiply the top by
2.
and the bottom by
3.
3. This sounds familiar, right? And so the top equation is going to become what here, Maddie?
6x plus 4y equals 54.
All right, and then we multiply the 3 through the bottom, Audrey, and get
-6x, -12y equals -54.
And thoughts on the x's, class? Thoughts on the y's? So what's left on the left? 0. And then on the right-hand side, 54, -54, class? Cancel, so I've got 0. Does 0 equal 0?
Yes.
That is not a contradiction. This is an identity. Remember? It's always true that 0 equals 0. So therefore, for an identity, remember, we said our answer is all real numbers. An infinite number of solutions. This is because these equations are dependent. If I graphed them, they would be coincident lines. There'd be infinite points of intersection. My answer is really indeterminate. And that's how we left it before when we graphed and we got coincident equations, or lines rather. We said, well, it's an indeterminate solution. We have too many answers to be of value. Do you understand that, Genesis? Okay, you look like you're falling asleep on me there. But what we're going to do is we don't really have all real points as solutions, correct? All real points are not solutions, so we can't say this. But we do have an infinite number of solutions, but all of them are in this line. So somehow what we've got to do is to describe this line. Does that make sense? All the points within this line satisfy the answer. So what we're going to do, write this down, for dependent equations with infinite solutions, for dependent equations with infinite solutions, and again, how will you spot this? You'll get everything to cancel. Literally, 0 equals 0. If everything cancels, you got dependent equations. If only one side cancels, that's your inconsistency, right? But if everything cancels, here's what we're going to do. We're going to arbitrarily use some other letter. And we're going to use it as what we call a parameter or a restrictive guideline. The most common parameter, we'll talk more about parametric equations next year for those who are going to be in pre-cal, but the most common parameter is t, okay, for time, because time is often a restriction on situations. So because t is a common parameter, we're going to use t, and we're going to use t as one variable. So step number 1 is to replace a variable with t. And we're going to let Michael, x or y, what do you want to make t?
X.
X? All right, so Michael's going to choose to replace the x with the t. It's that easy. Literally just don't write x, you write t instead. All right, then, since his x is t, then in my answer, the abscissas are all going to be represented by the letter t. We're going to represent the ordinates in terms of t. So step number 2 is to solve for the other letter. Solve for, in this case, y. He picked x to be t, so step 2 would be solve for y. Solve for the other variable. Well, if I want to get y by itself, first class, we got to ditch the 3t as a negative. It's less attached, remember, so we're going to get rid of the 3t first, and then divide everything by 6. Now, when you divide by the 6, if you can reduce, if you can factor something and cancel it, you'd want to, or what can cancel out of all 3 values, class? A 3, which means a 3 could be factored and canceled. If you knock a 3 out of everything, class, we wind up with? There we go. And this is the solution we will write for an indeterminate solution, because it describes every single set of coordinates that could exist here. This is how we represent the line. Question, Michael?
Can you do that all again?
Yeah, absolutely. Absolutely. Let's take a look at number 13. Make sure your brain is engaged. Number 13, copy it on your paper. Now, by the way, even as I'm writing 2x minus 10y equals 16, I think to myself, I could make that equation so much easier. Thoughts? Yeah, I could knock a 2 out of this, and what could it become? It's on your paper, right? It's in your book. All right, and we're doing number 13 there on page 235. And the bottom equation. I don't really want to write that down. Just look at the bottom equation. What could cancel out of everything? A 5. I'm going to write on the board for the YouTube viewers, and maybe for your benefit, though you're obviously seeing it there in front of you anyway. If I knock a 5 out of everything, what does my bottom equation become? Careful. 8. Got to know your multiplication tables. All right, knock 5 out of everything. And we can actually see right now, because of the reduced state, everything, class. Because they are literally the exact same equation. If you solve, you'll get 0 equals 0. Well, if they are the same equation, Are you listening, Michael?
Mm-hmm.
If they are the same equation, then when I graph them, what's going to happen?
0, 0.
No, if I graph them, you're not listening.
Oh,
if I graph them, what's going to happen?
Consistent lines, whatever.
Class?
What are they called?
Coincident lines. The equations are dependent. These are coincident lines. So one line, and the next line's going to be right on top of it, right? How many places do they intersect, class? Infinite number. My answer is indeterminate. And 2 lessons ago, that's what we wrote, and we moved on. We're in Algebra 2 now. We're not going to do that. That was Algebra 1. This is Algebra 2. So Algebra 2, we're going to say, well, I know the answer is indeterminate, but these points all have to follow a certain rule. Let's specify the rule that determines or indicates every single point that would be in this line. Because on the Cartesian plane, not every point on the Cartesian plane satisfies, only the points in this line. So I said, what we're going to do is we're going to introduce an extra letter. We're going to use the letter T, just because it's a common parameter. And I said, we're going to represent either the abscissas of all of these points or the ordinates of all these points with the letter T. In other words, either X or Y becomes T. Pick one, class. X. All right, so if X becomes T, we put that down. But we also come to this equation, and we replace the X with a T. From there, we get Y by itself. Now here, I'm going to recommend a double switch. Let's take the 8 and the negative 5y, and let's switch them to get, class. And now, finish getting the y by itself. Divide by 5. And when you divide away the 5, you'll get what for your ordinate? How will you represent the y values? Here's what this means. Any x value you pick, it doesn't matter what you pick, but its y value will be 8 less and then divided by 5. And that represents every single point that could possibly be in this line. So our answer is still an infinite number of points, but all of them follow this rule, if you will. It's like a formula to calculate. So, for instance, let's suppose I said, well, I want the t value, or the x value, that is, let's just say, let's go with an x value of 3. Well, what would the y value have to be? Well, if x is 3, 3 minus 8, divided by 5? Okay, that would be one of the points in the line. If I went with an x value of 9, plug it in, 9 minus 8, divided by 5, 1/5. You can tell this is not drawn to scale, right? But this, again, any of the points that are in the line will fall into this rule. Okay? That's all we're doing with the representation. So again, if you get everything to cancel, pick a letter to be t, represent the other letter by getting it by itself. And we're done. Does that make sense? This is for dependent equations where everything cancels. Again, if only one side cancels, you get 0 equals 7. Well, what's that, class? A politician. It's a lie, right? It's a lie. So we would call this an inconsistent system. And we get no solution. If they get a lie, they have no solution, just like a politician. All right? If it's not a lie, it's a truth, always a truth, then we need to represent the truth using the parameter. All right, let's go and take a look at some word problems now that use these. You'll practice more with that later on. So let's take a look at some word problems that use systems of equations. Go ahead and read this first one out loud for me, if you would, please. Abby.
The sum of 2 times one number and 3 times the second number is 34. The sum of 2 times the first number and 5 times the second number is 50. Find the numbers.
You realize if we stopped after the first sentence, there would be an infinite number of answers you could give for the first number and second number. By giving you a second piece of information, there's only one first number and one second number. How many unknowns then, class? 2. And they are, writing this down on your paper, the first number and the second number. Now, up to this point, every word problem we've solved, you pick one to be x, and you've represented the other in terms of x. We're done. Now we have 2 unknowns. One's x, one's y. From here on out, if you have 2 unknowns, one's x, one's y. You might want to jot that in your notes. So when it says in the first sentence that the sum of 2 times a number and 3 times a second number is 34, how would I represent that statement algebraically, Kendall?
2x plus 3y equals 34.
Absolutely. At your seats class, when it says the sum of 2 times the first number and 5 times the second number is 50, write down that second sentence or that second equation. Write down your second equation. Michael, what did you write?
2x plus 5y equals 50.
And to solve for my two numbers class, I just solved the system of equations. Definitely want to get rid of the x's, right? By changing all the signs in the top, because that's where the little numbers are. Let's be lazy, right? The two x's and negative 2x cancel. I get 2y equals 16, so y equals 8. But I'm not done. That's only my second number. I need the first number still, right? So what do? Plug it back in. I messed up the top equation. I'm going to go to the bottom equation. Plug the 8 in for the y. 5 times 8? Subtract away the 40. Divide away the 2. So what's my first number? 5. So 5 and 8 are my two numbers. Quicker, easier way, I think, of solving double unknown problems using the system. Read this problem for us, if you would, Audrey.
The sum of two numbers is 18, and the sum of the first and 2 times the second is 20. What are the numbers?
How many unknowns, class? 2. And they're simply the two numbers, right? So the first number, second number, kind of like last time. How do I represent two unknowns from this point forward? X and Y. We're not going to put a whole lot of thought into it anymore, just X and Y. There we go. How do I write my first equation, Maddie? There we go. The sum of two numbers is 18. X plus Y equals 18. How do I represent the second equation? How do I write that, Genesis? There we go. X plus 2y equals 20. Once again, class, we want to get rid of the x by changing the signs in the top where the little numbers are. Not much littler, admittedly. X and negative x. Negative y positive 2y. Negative 18 positive 20. And there's my second number, 2. Go back to the original, or here, and plug in the 2 for the y. 2 times 2? 4. Subtract away the 4, what do we get for x? 16. So my two numbers are? 16 and 2. Easy enough? Let's do another one. This one's a fun one. I'm going to read this one, if you would, please. Brandon.
Find two numbers with the sum of 5 times the larger number and 4 times the smaller number is 26, and the difference between 4 times the larger number and 2 times the smaller number is 0.3, more than 3 times the smaller number.
All right, so this time we got two unknowns again, right? But it doesn't call them first number, second number, class. It calls them larger and smaller. Okay, so we're going to go with large and small. And how should I represent my large and small? You could do X and Y. You could do L and S. My only concern with L is it could look like a 1. And S, if you don't write it correctly, could look like a 5. X and Y look like X and Y. So I'm a big fan of X and Y. How would I show that the sum of 5 times the larger and 4 times the smaller is 26? How would I write that first equation? Abby?
5x plus 4y equals 26.
There we go. Now for the fun one. It says the difference between 4 times the larger and 2 times the smaller is 0.3 more than 3 times the smaller. At your seats. Write it down and I'll call on someone in just a moment. The difference between 4 times the larger number and 2 times the smaller number is 0.3 more than 3 times the smaller number. And let's call on our smaller student, Kendall. What do we got here?
4x minus 2y equals 3y plus 0.3.
Perfect. How many had the same thing Kendall had? Questions on that? Now this is annoying, because as I look at this class, I've got like terms lined up, right? My x, my y, but that's in the way, isn't it? Well, if it's in the way, let's move it. And if I move it, it becomes a negative 3y, which ends up giving me a negative 5y. And this is equals 0.3. I hate decimals, but I could get rid of the decimal, class if everywhere in the bottom equation I just moved the decimal over once. Well, what does this equation become as I rewrite it now a second time, just moving the decimal over once? Stay with me.
40x negative 50y equals 3.
All right, now then, coming back here, this is my top equation. This is how my bottom equation looks now, right? I got rid of the 3y, so like terms lined up. I moved the decimal, so I didn't have a decimal anymore because I hate decimals. X, y equals number. Do I want to get rid of the x's or the y's, class? I'm thinking the x's here, and I can get rid of the x's if I multiply this top equation, class, by 8. Calculators at the ready. Shouldn't be hard for the first part, 40x, or the second part. But the last part, you're going to want the calculator.
208.
208. And there's my system now. Will the 40x's cancel? No, they're not inverses. So I need to change the signs in one of these equations. Where would it be smart to change them? My old bottom equation, right? It's top now the way I've got them written. Let's go here. This becomes a positive. That becomes a negative. 40x and negative 40x?
0.
Cancel. And 50y positive 32y. 82y. And negative 3 and positive 208. 205. And, yeah, well, 5 by 82 comes evenly to 2.5. It doesn't surprise me that I got a decimal, right? There was a decimal in the original equation. Shouldn't shock me. Let's go back to one of my two original equations. First or second? First for sure. Plug in the 2.5. 4 times 2.5. Subtract away the 10. If 5x equals 16, divide both sides by 5, what is x? 16 fifths, or let's go consistent with a decimal. Go ahead and divide it on the calculator. 3.2. So my larger number is 3.2, the smaller is 2.5. Was it pretty? No, but it wasn't hard either. All right, your homework for this evening is to do page 243. Page 243 in the review section. Remember to specify this time. Page 243 in the review section. I want you numbers 1 through 4, 6, 8 through 11. Page 243, numbers 1 through, in the review section, 1 through 4, 6, 8 through 11. We'll look at more word problems, we'll look at more systems of equations, and we'll introduce a third and sometimes better way to solve systems in our next lesson. Have a wonderful rest of your day, and you are dismissed.